Good morning to everybody. Hopefully you all manage to join on time. Welcome to the RAS EAS Workshop that is organized for the first time by the European Aquaculture Society. So the aim of the event is to bring together key figures from the science and the industry to present the latest knowledge on the recirculation aquaculture system, discuss challenges, but also share experience on RAS for different species. So as you know, recirculation technologies have been improving a lot over recent times, and they offer fantastic opportunities for farming a broad range of aquatic species from all over the world. But also we can farm them in a controlled manner and to supply year-round production. So there are many key benefits from the systems, which include, of course, reduced water usage or improve management of waste and discharge and biosecurity. However, many gaps in knowledge remain to optimize the use of these systems. So the RAS EAS takes a different approach than the usual scientific sessions that we usually run at the EAS annual event. Each RAS EAS event is organized around panel discussion on specific challenges on recirculation, with several sub-sessions based on interactive discussion and audience participation. So the panels are composed of experts from both industry and academia, and we're planning to make the RAS EAS a regular event organized by EAS, with the next one planned for Rimini in 2022. Okay, so today is the first RAS EAS workshop, and it's entitled Creating an Optimum Environment, and it includes 3 sessions. The first one will focus on disinfection strategies using RAS. The session will be moderated by Jaap van Brien from the Institute of Marine Science in Helad. An introduction will be given by Chris Good from the Conservation Farm Freshwater Institute in the USA. Then we move on to the second session on RAS monitoring and autonomy. And this session will be moderated by Øyvind Fylling-Jensen from Nofima, with an introduction from Bård Skjelstad from Skjelstad. And finally, the third session, we will discuss interactions between fish and RAS environment. And the session will be moderated by Daniel Turner from BIM in Ireland, and with an introduction given by Jelena Kolarevic from Nofima. It's based on the level of interaction. So please feel free to ask questions, use the chat function, but also challenge our panelists. And I'd like to thank also all the session moderators, presenters, and panelists for contributing to the event.
Good morning, everybody, and welcome back to this session 2 of the RAS workshop at European Aquaculture Society, Creating an Optimum Environment. I'm Øyvind Fylling-Jensen. I'm the CEO of Nofima, and I will be leading this session and panel discussion. With me today, I have a distinguished panel of members with more than 100 years of experience in the aquaculture industry. It's a broad experience and a big topic, and a part of this workshop we will be discussing automation and monitoring, and also autonomy of the RAS systems. Before we start, I will just introduce the panelists, Bård Skjelstad, who will be presenting a short video as a starter. Then we have Bjarne Hald Olsen from Billund Aquaculture with us. We have Nikos Katribouzas from Avramar. We have John Richmond from MOWI, and we have Eleni Kelasidi from Sintef Ocean. A panel consisting of people with both academic and industrial background, but more maybe industrial and operative backgrounds than the pure academic side. I hope that you will be using the chat function, asking questions to the panelists, and which we will move on and try to answer during this 1.5 hour we have set aside. But before we start, please roll the film with Bård Skjelstad. Thank you.
Hello, everyone. Nice to meet you. I was asked to give a few thoughts on automation and monitoring in RAS systems, and maybe raise a question or two for us to debate. I'll share my screen with you and hopefully be able to come up with something that we can discuss. As I started looking more structured into this, I actually ended up asking myself, why isn't more happening? There's a lot of knowledge, there's a lot of curiosity, there's a lot of hardware, software. It seems as if both the market and the supplier and academia, everyone's keen to see this happening. So maybe the right question now is also, why is it not happening faster, more broadly than it is? And that ended up being my perspective on a lot of my thoughts around this. Now, I think that we need at first actually to start and be very precise on what are we actually looking for. I think that's part of the delay, if we can speak about the delay. What we're looking for when it comes to automation. There's a lot of different opinions already here, and that's not good if you want a rapid development. I think that many suppliers overthink this, overthink the maturation and the curiosity and the willing to pay for this and that within the market. So to be very aligned between the farmers and the suppliers around this is crucial. And I'll get back to that, but for me, I'm quite convinced it is not about the comfort. It is not about reducing staff or letting go of manual work because it's convenient. That it is not a strong enough driver. So maybe then again, what is it? Well, those questions should be very visible, but are they really? What is the market looking for? What kind of questions do they ask? And if the suppliers have ideas around this that they are not being able to utilize, how well are the suppliers on actually telling the story, giving the examples and giving proof of their thoughts around this? I think we both should look at that again and develop this maybe on the background of a kind of a new entering this together with a new energy around the curiosity for really lifting the lid of some things that we maybe sort of forgot almost over the last years. My experience is from the salmon industry, so bear with me with that. But it's my experience has been pretty much like this. It seems that we're always in a rush, and although we start with a very exciting discussions about what a new, fully well-designed project could be, we often end up looking at the timeline because we have a deadline, because we need to open, because we need to reach the season and the production, and also then end up in the end with good enough, which is fair enough, I guess, but it's then back to the basic functionality. And the curious thing there is that these projects, they are becoming larger and larger, so good enough is sometimes based also on experience made from smaller projects. And of course, there are issues around this that might not be the best always. So we need maybe to get out of the rush and work a bit differently. That's really something I think should be looked at. And for me, based on that, I think that automation can help. And I think that it will help mainly if it reveals and enables. So instead of comfort, as I said, instead of just doing something for a cost there and then, we should find those very good value creation examples and hypotheses that helps us together to reveal, because there's so much we do not measure, we do not understand. And as I said, we're building larger and larger sites. So there are more and more, it's more and more obvious for us that there are things that needs to be revealed. So let's take a look at how we could maybe get around to doing that. My logic is very simple. It's all start with the feeding for me. Keeping fish in a closed loop like this isn't really difficult. The salmon, at least, is very robust. It can take a lot of different water qualities, whether it's temperature or it's particles or whatever. It can take a lot of different situations. So experience-based, if you're looking for survival or supposedly fitness, in just keeping the fish there, fine. It seems simple. Our challenge starts for real when we're adding feed into this. That's when the fun begins, and we're all aware of this. But let's stop for a while and see what are we actually doing here. We add feed. We know that something happens that we need to deal with, and the idea is that our technology cleans up the waste, which is now a part of our fish environment, and we're back where we want to be. And pretty much this is the case because we've been very successful in developing an industry, a big industry, with a good utilization of this new husbandry farming situation. But still, how aware are we that this is actually what we are achieving? How well do we evaluate our own plan and technology all the time, in every situation? And as I said earlier, in situations that are actually new to us because we have built bigger, we have more fish, we're doing it a bit differently than. How well do we evaluate this? To my knowledge, not far enough at all. What we should do is to automate these processes, both the supervision of the environment and from the beginning, the whole feeding, the feed supply, the feed stop and start, the feed impact. Everything should be monitored. This has to be done by automation and monitoring, because to do this manually would be, hopeless. So this is precision farming, and that's what we're moving into. We have to move into that. And it's all about, as you know, precision farming is something we'll be speaking about all day, I guess. It's all about this observation, interpretation, decision making and acting, and to get that together and automate it. And for me, I reckon it starts very much with the acknowledgement that we do not even observe, and far less in a structured way. So let's not forget about that. Automation is even if you find the right things, the right motivation to do it, there's a structure to our data here that needs to be in place. And we must not forget that that is not in place as of yet. A few examples. If this is the value chain, I think it's very important to help the industry reveal and the biological impacts that are more subtle than just survival or just growth in a certain phase. They need structured data and structured data from continuous monitoring over time. I'm pretty sure about that, and it's not a very original idea. I think we all agree on that. So, but they're subtle, and so therefore, I think part of the problem why we are not being asked about this more and why we haven't delivered these systems already is that, for instance, a biological impact later on from something in early life leads to the idea that you need to invest in redundance and control systems and stress monitoring or whatever in your early phase, your hatchery systems. It's an investment, and you're not absolutely sure what that would bring you. But you come along with the idea that probably there's something there, but as long as you don't see it, this doesn't happen. On the other hand, when you experience something that you might think is down to something else connected to this, you end up with the same problem. You experience, but you can't prove it, you don't have the data, and you never get out of this situation. I think it's caused by this. These are subtle connections, biologically speaking, already, and since for salmon we've been transferring the smolts, there's all kinds of other bias into this. And there's all kinds of different people, different challenges, different key indicators. So the subtleness sort of hides everything, and we never get around to share that value creation and address it. I'll get back to that in a minute, but also another idea is about the hygiene, the cleaning. We create complex system, more and more complex system, but we don't seem to automate this process of cleaning. And it's a mystery to me, because we do that in pretty much any other industry where there's long pipes included. We do that when we sell our feed system. It's crucial that people have a good routine of removing the biofilm in those. The oil industry does that because they have to. Why don't we do that? Where's that question gone? It's gone on along the way, and now there's a big focus on the biofilm, on our capability to disinfect, all those things. So why not even these systems? Because this is not hard to do if we design for it. Maybe we're caught up in this, the Pareto principle, where you learn that the focus should be on the main drivers, and that will bring you pretty much all the way, but maybe not all the way. And I think this has been a success, this kind of thinking, if I'm right. It's been a success because a lot of things have happened, and we're pretty good at producing our fish and holding and farming it already. But if we establish that basic functionality, we need to acknowledge that improving it will not be as easy. It takes some effort, but it's a possibility, and it's probably also a necessity in the long run to be sustainable and to survive as an industry. And what's it all about? Well, we need to change that thinking. And it struck me, because I'm being an audiophile, it struck me that I think completely different on my hobby than I do when it comes to the industry in my work until now, because as an audiophile, you establish your basic functionality just as a starting point. You put most of your investment into that. You buy your speakers and your amplifier and your source, but that's just to get going. It's from that and from the quality of that you're able to start tuning the details and find the magic in an expensive pickup on your turntable or a new power supply to your amplifier. And you couldn't start in that end because you wouldn't find the details unless you had a good functionality, basic functionality, but also you wouldn't find magic if you didn't. So there's maybe a lesson to learn from that way of thinking. And the market within hi-fi, things like that, which is why you get those products as well. So we need the market also to acknowledge and to chase the details to find the magic. I think this is about to happen now, and I'm very glad about that, because what we see now in creating grow out, big sites for grow out, is about farming large fish. And that's something that we've been doing for a long time, and we have a lot of experience around. So what I'm thinking is that land-based and sea-based are now merging in a way. They're getting closer, and they will start sharing both the same challenges in the more and also the same experience. And I think that will make things happen. We'll find ourselves getting the new questions from the market, because there are new owners thinking maybe in a different way, but also because large fish farming is a common thing. Now we're doing it in a new setting, and we can probably easier see the results of the connections between also the biological aspects all through the value chain. And I'm quite sure the suppliers will come up with good system products connected to this if the market wants and starts asking for them. Lot of things to grasp here, lot of things, and you know this more and better than I do. Of course, it's about the environment factor, but it's also about the fish behavior, the stress, the pathogens, the management, the maintenance. It's about logistics. It's about the results and impact from logistics. It's about vaccination. It's about everything. From where I'm sitting, I know where I'd start. I'd start with feed control, because that's the beginning of all our challenges. I look into behavior, because our tanks and our populations are growing. They are big, and we need to understand them. And I'd start also looking at the subtle effects from my environment, from different phases, and how they connect. That's pretty much what I had in mind for today. Thank you very much for your attention.
Thank you very much, Bård. A great presentation with this very nice way of putting forward a rather complex topic. It seems to me that we have some challenges getting Bjarne in on the presentation, but they're working on it right now, so I hope they will be able to solve that in a couple of minutes. I would like then now to continue by having the panelists to present themselves very briefly. And I will start with our female participant. I'm happy to see that we have women on the panel. So Eleni, please, could you please introduce yourself?
Hi, thank you, Øyvind. My name is Helene Kelasidi, and I am senior researcher working in Sintef Ocean in Norway. My background is from cybernetics, and I have a master PhD and a postdoc all on automation and robotics. And now I'm working in the aquaculture operations and robotic groups in Sintef, where we are developing solutions towards sea-based and land-based aquaculture. Thank you very much.
Thank you. John, are you next one up?
Hi, my name's John Richmond. I work as the freshwater manager for MOWI Scotland, so look after the production of our fish from egg to smolt. We're producing around 20 million smolts per annum now in MOWI Scotland. We have one small flow-through hatchery, 2 large recirculation systems, and 5 freshwater lake sites. And it gives us a bit of a unique perspective, because the lake sites are a very good environment for producing smolts, and not something that many other companies have now. A very stable water quality, low density, low CO2, and it sets a very high benchmark then for our smolts coming from the recirculation facilities. So that's what we are endeavouring towards, is to make all our smolts as good as the lake fish, and perhaps automation is one way that can drive this forward.
Thank you very much. Nikos?
Hello, everybody. My name is Nikos Katribouzas. I'm the genetic and R&D manager for Avramar. My background is biology. I'm in the business for 27 years now. Most of the time spent so far was in hatcheries and farms. Actually, today Avramar has 8 hatcheries and 4 pre-growing units. Most of them are equipped with recirculation systems for fries. So we go up from recirculation from half gram until 10, 15 grams, and then we go to grow out. And all the systems were made through time, developing one after the other, making one more sophisticated than the previous one. So we think precision farming is the way to go. And we're looking forward to the new technology and the new improvements that are coming from the industry partners.
Yeah.
That's my part.
Great. Bjarne, who will be joining us, hopefully, he is the Chief Operating Officer and Business Development Manager of Billund Aquaculture. He has a very broad background, working with 18 different species, from rainbow trout, barramundi, carp, eel, perch, pike, tilapia, and so forth, and has more than 36 years of experience in recirculation hatcheries. So let's just hope that Bjarne will be able to help us going forward. And then to you, Bård, who are you? Bård? Yes, please.
Yeah.
You're muted.
Still?
No.
There you are.
There you are.
Sorry about there's a delay there. Sorry about that. Hello, everyone. Yes, I'm Bård Skjelstad. I work as the CTO of Scale Aquaculture. We are a supplier of technology to the industry. We have been building turnkey systems up until now. Now we are directing our focus into technology systems and supply systems into different farms of aquaculture, mainly in salmon, but also in other species. I'm a veterinarian. I've been working in the industry for 25 years and pretty much all over the place with all kinds of problems and in different companies. I'm very happy now to start to try to increase the biological focus also within the technology part of the industry.
Thank you very much. I feel that there is a saying that we should put forward, and that's you can't fool biology with neither technology nor money. But what are the major trends that you see in the aquaculture RAS automation part? And maybe I start a question and put that forward to you, Bård.
I think it's actually a clear trend visible now if you stop and look for it, and it's quite recent. But because I think that's the explanation, because of this very rapid emerging curiosity and investment willingness to grow out on land, there is a lot of things happening. There's a lot of new players, as I said in the presentation, and I really find from having meetings with quite a few of them over the last 6 months that the new questions are emerging, and I'm very keen to see how it will end up, because of course if we cannot supply and together find that value creation, I'm a bit afraid that it will stop again and we'll get back to that cost. And also if the market sort of come into a more stressed situation where you'll be realigning your focus on the investment. But for the time being, the situation is very good. There's willingness there. There's money to be earned, and therefore I really feel that we see a pattern of very much curiosity, especially around automation of feeding. We have questions on that, and I do not know any systems that are applicable to the industry today, but I think there's a lot of different suppliers and environments working very hard on that. So that is a trend visible as far as I see it. and nothing else really. Everyone talking about the size element and that things need to be done in a different way, but I haven't really met that in that aspect. That's more an abstract curiosity, but around the feeding, I think that will open the door. I hope so.
Any comments to that from the other panelists? No, because I think there is a question when we look into the technologies and monitoring, and where should you say in your presentation, Bård, that you should start by feed monitoring and the feeding, and you said it briefly because it's the biggest cost factor, but how easy is it to make good monitoring systems for the feed operations?
Well, I think it's something that we are fully able to do together. This is not a sales meeting for scale, so I don't want to go into what we're doing, but we're doing a lot on this, and we will launch a system around this, and I'm sure many others will as well quite soon. But so what strikes me is very much the motivation, because we are selling a lot of feeding cameras to the seas. I've been doing that for 15 years. And also we have launched Pellector, which identifies through the camera and helps you with your surveillance of non-eaten feed. And there's actually commercial systems on automated feeding on the seasides, which is much more difficult to achieve. And that's run by, as you said, it's a big cost. But I think in the land-based industry that's emerging now on the grow out, this has to be in place, and it's not only about the cost, it's about this is the major risk you have for your whole water quality and the environment you are creating. So you need to be in control of it. And also I might add that I find it a bit peculiar that we're still discussing nitrogen supersaturation and CO2 levels that are not optimal and things like this, because this is knowledge that we have. And when it comes to nitrogen, it's one of the oldest known difficulties that we have from the environment. And if you change the temperature, there's always emerging a debate whether you're moving into some problems. And still, I'm stunned to see the level of automation around that. It's all handheld as far as I see, monitoring retrospectively. I really find it quite special that we haven't moved further on that, things like that. We're fully able to do it.
We'll come back to the questions from the audience, but I have a question to you, Eleni. And you mentioned, and Bård also mentioned the word in his presentation, precision aquaculture. What does it take to move us from what, if it's not precision today, then it's rather coarse. What will it take us to move into precision aquaculture on the automation and the monitoring side for you as a cyber and data expert?
Thank you, Øyvind. Yes, as Bård mentioned, precision fish farming, it's the way and it's the goal. And I think both the research academia and the industry sees the same. And that's very happy to see since this method was introduced in Sintef. So what I think I would see there is that, as Bård said, there are 4 steps on the circle to reach precision. It's to observe, interpret, decide, and act. But what will take to get this is that in order to observe from manual and sub-objective ways, we need to have new tools, sensors, and new stuff to measure, right? So there should be a lot of way from the technology providers and the research to develop these sensors that have lack of precision, so real-time measurements on storing this data and all these things. And then when it comes on the interpretation, we have a lack of methods on how to combine. So for instance, if we take measurements of the environment, of the fish behavior, from the water quality, how we can take all this and have methods that can really represent the data to the fish farmer, to the industry, to the research, that we can use afterwards on the missing proper visualization tools and decision support systems that can really tell something inside on this before we reach what we want to, like automate the feeding, automate the cleaning, automate all these things. How we need to go this full circle that we have all this information, and of course we are lacking real-time control of these systems. So we need a lot of data to control them and that they can operate themselves. There are lack of robotic solutions, for instance, cleaning of the tanks. There's not much on it, and how they can operate autonomously. So I feel like there is a lack both on the equipment on the market out there or the use of them, and also methods that need to be delivered so that it can show the impact to the fish farmers and to the industry.
Yeah, and that takes me actually a question back to John and Nikos, who are farmers. So John, what do you think is the biggest challenge then?
I think in my industry, in the smoke production industry, one of the challenges that we have is that it's not just about the system that we're growing the fish in fresh water, it's how those fish then perform when transferred into seawater. And it's that transition between one water quality and the other that can quite often be the most challenging for the fish. So, you know, we mentioned earlier CO2. Well, we know that we need to keep CO2 levels low, but how low? And it's a huge consideration because there's a massive economic impact in terms of the level of CO2 that we want to target within our systems. To get down to lower and lower levels, you're in a kind of exponential relationship of more and more effort and operational cost. So we need to find that kind of sweet spot that is delivering the right thing for the welfare and the performance of the fish. But then that's confused when you transfer the fish to sea. There's 1,000 other challenges that can muddy the water. So I think research has a part to play there, where they can help. We're involved in Robust Smoke project at the moment, looking at specifically these sort of issues, where in a more controlled way try and identify the optimal water quality, and then use monitoring in the future to achieve that consistently. I agree as well that feeding is the key, as in all of fish farming, and especially so in a recirculation system. So I do see a lot of opportunity there to have more sophisticated monitoring of our feeding. And again, we have the opportunity where, you know, all of our waste is coming to a point in the systems. We don't necessarily need to use seawater style feed monitoring systems. There could be other ways to do it in a recirculation system. So good automation that helps us uncover more information about the fish, as Bård discussed in his presentations, where we want to go. We've had lots of examples of that being done poorly, automating things that don't really need to be automated, not being done safely. You know, a single probe looking after a critical part of the process that can break down. So that needs to be thought about as we move forward as well.
Thank you. Nikos, a few words from you before I start going into some of the questions from the audience.
Yes, I would like to say that the biggest challenges as we face it in Mediterranean bass and bream hatchery phase would be sensor reliability, and every time you have an alarm, the first thing you think is the sensor working? So you have to go and check, and auto calibration and control of calibration versus a standard is essential in order to trust the system that you automize And also manual override is necessary for us in real life because Murphy's law exists and things will break, and then you need to keep your fish alive and well. So we need to trust more on the sensors that before we give the control to the sensors. And there is a long way to go from where we are and where we were to where we should be. That's the biggest challenge I see.
Well, that's good, because that actually takes us into a couple of the questions from the audience. There is a question here: which technology or combinations of technology are currently viewed as the most promising ones to obtain this precision farming in the future? And the second, which is also to the whole panel, has anyone experience with direct monitoring of fish behavior? Is there a product available on the market for monitoring fish behavior? Maybe you, Bård, could start off on that one.
Yes, I can see from questions that the people are asking what kind of, where are we looking, and what kind of, you know, meetings are already taking place to consumers and to customers. Maybe it's from where we come with you know, the other products that we have, but we find that there's a big curiosity around using cameras, machine sight and AI, and that has also emerged quite rapidly the last year. We've been involved in projects around this, and I find it also very interesting that now more and more companies are trying out technology to have closed pens in the sea farming, and that also triggers a different audience into this, and they are also coming back to us asking the same questions. We want to understand what's going on in this pen, and we want to look at the behavior. We think also there are other drivers from sea farming industry that will trigger this, and yes, we have been looking into that. There are more and more startups and even bigger companies working with this. For me, it's very much about the data structure. I think that the integration of these different perspectives maybe is our biggest question at the time. We have the knowledge, we have much of the technology, but we are not integrating it in a very good way. Probably a lot of reasons for that. I think also one of the reasons is that many farmers are a bit, you know, cautious about sharing data. Maybe think that it will get them into, you know, losing control or whatever, or losing the voice into this, and be caught up in something in products that will not actually utilize a value according to what they wish. So they want to take control of that themselves, but they are doing other work, so it takes time. I'm not sure, I get that idea sometimes, but for instance, the behavior, especially in these big tanks, is definitely one of the drivers, and there's a lot of interest on that. I think on redundancy, to keep, we already have automated like CO2 degassers systems, and they are fully functioning. I don't know why that isn't the standard. I'm not sure they are fully available, but they're working. And also on the cleaning systems, we find many companies working with that. A bit different approach, whether it's convenience, whether it's, you know, documentation, things like that. But I think that camera technology, and of course the integration systems on software is crucial, and those are very very visible as driving environments and technology into this. I think I'll stop there now. There's more to be said.
Yeah, but if you then take a look at this, I'm sorry, I get some feedback here. But if you take a look, that you mentioned data structure, and John and Nikos mentioned the fish behavior and that part. And the data structure, is it so that you're not able to monitor in the right way, that the data is too late because it's not real time? and that you're not able to do pre-active decisions based on the monitoring systems that you put in place? Bård, you're muted.
This is not, it's about the integration. We are able to do this, but we're not doing it because there are different, different suppliers and different people involved, and we haven't actually worked out the integration. I think that's part of it. We are able to do that job, but we have to work a bit differently to achieve the fully and to fulfill that optimum way of doing this structure. So the structure is very much, actually, I would like to say that some of the work meetings that we have during the last 6 months with Sintef and others that in projects that we have, we've sort of debated ourselves back to the starting point that we need to address the data structure at first because it's still not in place, because there's so much more we could do. So it is a problem that is not solved yet.
There is a comment here that it must be more than curiosity than in making this decision. Could one of you put forward some comments on what are the automation trends? Eleni?
Hi, I completely agree. The curiosity is the first way, but we can't put a lot of effort, value and all to develop solutions only, even though as a researcher, I would love that. That would be the driving force. But we need to develop the automation solutions that will have impact to the farmers, right? So they need this and they will not produce problems. So I'm afraid sometimes that some of the automation that we produce, it might increase the complexity and all these things. So with Bård and with Scale, we have a project that we were running on this, and we asked our fish farming companies as a partners, what are the trends and operations you want to automate, for instance? So which are the most essential ones? And what came out of this survey is that the trend is like the cleaning, one of the ones that everybody agreed that it is essential operation we need to go. Feeding, for example, splitting the fish. So different partners are putting different trends on that direction. But at least in Norway, correct me, Bård, I feel like lately there has been at least 3 companies out there like trying to do the cleaning with the robots. So we see that the tanks are increasing so much on the size that they are seeing this need that we can't really clean 40 by 40 tanks. So there should be autonomous solution towards that direction. So if, for instance, on the feeding, how we should automate, we can't walk on the farms with such pigs, and which areas to feed and when to feed and all these things. So I would say, like from the surveys, these were the 2 directions that we discussed and the trends in the automation moving.
So cleaning and feeding is of course obvious, and it was also addressed, the cleaning and part of it in the first session today about disinfection and bacterial counts and the water environment. But there is another that we mentioned, cameras. What kind of biometrics would you as a farmer look for, Nikos? What would you need to know? I mean, the best biometric tool we have is our own eyes when we look at the fish, but we can monitor millions of fish at the same time.
Yes, for me the biggest challenge I'm looking for this in the discussions with the suppliers is to find the system to have adjusting the environment according to what's happening inside the tank. Especially in our case, we have lots and lots of tanks, and we have in one tank, let's say 20 kilos of biomass inside, in the other tank we have 500 kilos of biomass inside. And we need to have a standard environment for the fish there. So we need different flow, different oxygen injection, and this is extremely difficult to manually set up as you change the fish from tank to tank every day, and it's complicated to do. So my first need would be to adjust the environment, also taking into account how much feed you put in the tank and how much dirty is the tank. So how we can adjust all of this to be uniformly correct for all the fish in every tank. That would be the main target for me.
And John, any comments?
Well, the same really, but in addition, our guys spend a lot of time just monitoring the water quality. There's maybe 10, 12 parameters we look at in each system, and we have multiple systems, and it's all done through little photometer tests, and there can be a lot of error in the data, and a lot of opportunity for people to just get it wrong in the application of the test. So online systems that can do that provide first and foremost accurate data, but then also more information that we can use in relation to the production within the facility. Too often it's just done to check that the gross things are okay, and that the fish aren't going to die. But the next level beyond that should be, where can we see the fish are performing best in relation to our water quality? And to do that, we need much better water quality data rather than just one test per day. So automation and monitoring would help not only massively reduce the labour there, but give us much more information that we could start to apply to our production process to optimise that as well.
So you see that as a kind of direct feedback loops, as Eleni was saying, that you actually monitor, and then you have a positive feedback that is adjusting your water quality and your pH and content load, water chemistry, instantly in a system?
In some cases, yes, but I'm thinking less along those lines and more that, if we can see a profile, for example, of let's say nitrite in the water, and we see that one population of fish is performing better than the other, and we can start to draw trends and correlations. It helps us refine those kind of suboptimal effects that the water quality can have on the fish. So say at the moment we're just grossly looking at how to keep the fish alive, and if they're performing okay, then it's okay. But we do know that on occasions we can have some populations that just seem to do a lot better, and we don't yet fully understand why that's the case. And it's not just in the systems, it's when you move the fish between the systems, it's when you move them out to sea. So yeah, gathering the data to help us understand how the environment is impacting on the fish, I think that's a key way forward for us.
Bård, please.
Yes, I really agree with what John is saying, and I can also see from the chat that one of the audience is asking about this. Why don't we focus on information to make better decisions? And I totally agree. I think we need not rush on it, but so maybe the thing we are discussing is automating the data structure, automating the basic information that we need, and then for the next step is to automate the sort of the action. But let's automate the data sampling for a start, because I totally agree, and I must repeat that what John is pointing to as well, on to understand those, why is someone performing better. There's so much knowledge there, but it seems like we're almost exhausted in actually trying to solve that riddle, because we don't do it, and hasn't been much change in actually since, let's say for salmon, we experience, and everyone knows today, that you keep your fry or your eggs at 8 degrees, and you should go above that because then you move into deformities or something. But then that's the figure. So we think, like, we live in this world where we think that's the limit, where we see it very clearly. So let's stay behind that limit. And the logic then being that that limit is very clear, so that on with this side, then there is no impact. Of course there is. So how to reveal that? It's much more complicated to reveal that. But why are we not chasing that? And there's, to start in that end, why do I repeat that? It's because that's the easy way to start, because the hatcheries are smaller. We could learn a lot and get a lot of energy if we did things right there. There's so much we know on heart health, on muscle development, on deformities already, and even those data which are environmental are not being structured, automated. So it's back to that. Why are we not already doing this? That's not a big cost.
So, from what I understand, and it takes us back to the data structure and the data layout and the interpretation of the data, rather than our ability to collect data. We have a question, or do you have a comment to that, Eleni?
I just wanted to add on this is that I completely agree, the structure of the data, but as I have the fear that the data, I told this with Bård and discussed a lot, that data that are not gathered with a special need can be just a space on a hard drive or a server, or just a noise. So when systematic data gathering should also include of which data and when which method will be used to analyze this data. So for me, it's just a space if we don't also consider where we are going to use and what useful information they will provide us. And this should be on the standardization of which data and the structures that we collect. So this was just a small comment.
Did you put up your hand, John? Please.
Yes, no, just again to reinforce and agree that we, in our company anyway, we are very good at collecting lots of data that hides in a hard drive somewhere, never to be used again. We need very specific hypothesis as to what issue we want to resolve. So just to give an example, we see nephrocalcinosis as an issue in some of our systems, but it's quite difficult to understand because it's a multifactorial thing. But there's enough information there now that talks about not only the CO2, but the type of hardness in the water, the phosphorus levels in the water, that we could now start by asking the question, what is causing more severe nephrocalcinosis, and monitor these parameters together and try and correlate that with our observation. But structure it first to say this is the question we want to answer, so that we make sure the data is then collected in a way that we can answer that question, rather than just go out there and start measuring everything, and then it will just all become lost and too difficult to manually go through it all and try and find any answers from that. So yeah, I totally agree that that's a real consideration to start.
Thank you. And water chemistry is, of course, a major issue here. There is one question from the audience, that are anybody putting in measurement systems for smell or taste of the water, not only the turbidity or the chemical side? And it also links to another question, which is how often should one monitor, for instance, for nitrogen or for other byproducts? Bård?
Yeah, I'd like to comment on the smell thing, because I've run broodstock farms for many years, and that discussion keeps jumping up there, because when you reuse or recycle your water there, you always end up with the question whether there's pheromones or hormones actually having an impact on your whole population if you try to divide your population at different fertilization phases, things like that. And we're never able to get around it. But I think for me now, I think another part of the sort of same thing is the sound. I've never seen anyone work precisely, except maybe John and his group, on what impact has noise on the, and there's so many designs, so many, especially specific tanks all over, which have an incredible amount of noise directly into the environment, and what that does to the salmon or the fish in general in there. It is something that I'm very, you know, it's strange that we do not focus more on that, and there are indications that it has a great impact on, you know, the stress, the thrive, the performance. And I'm especially in the early phase of, as I said many times, it's very easy task to monitor, very cheap to monitor. With we tried, and there's just no end to it, where you can start, and it's easy to improve, easy to come up with hypotheses, but that's any structure work around it. So there's a lot of those questions are able to be asked, and I really fully support them.
Eleni, please.
I just want to tell you, Bård, that we just granted the fish machine interaction project from Research Council, and the goal is to do exactly what we're talking here with the fish behavior, how it reacts to the sound, how it reacts to emotion, how it reacts, for instance, to color, how it reacts to some currents, objects, colors, and this, I think, also that will give good questions on the fish behavior products and questions on that earlier some posted.
Thank you. John?
Yeah, we had an interest in this in our facilities, thinking about, again, transferring to the sea. An observation that we had when our lockfish go out to sea, they have a very similar feed system to the seawater systems, a spinner in the centre of the pen, and so when they go to sea and the feeder goes off, they all rush towards it, knowing that that's their food. And the hatchery fish, when they go to sea and the feeder goes off, they all run away from it, thinking, you know, what the hell's that? It's something that they're scared of. So we thought, well, what about we try and record that sound and get the fish used to the idea that that sound that they'll hear when they transfer to sea correlates to this is the feed coming, because we could see very well in our own systems that the fish are trained to the auger screw feeder. You can go there and hand feed and get no response, and then the auger comes on and they all come up to the feed. So they're trainable fish, and the behavioural aspect of the fish is something that we just most often discount, but I think can have actually huge impact on giving us some success. And yeah, we haven't quite finished that project, but it's shown some early promise that we could do something there to essentially pre-train our fish to the new environment that they're going to. So yes, I think there's more to look at there for sure.
Nikos, please.
I would like to answer to the question about the frequency of monitoring of parameters, and this is if you have to do it by hand, then you do a quick survey to see where is there the higher values of your system during the 24 hours, and then you focus on this particular period of time. For example, we know since we're feeding in the morning until the afternoon, the highest ammonia counts will be in 3 hours after the end of the feeding. So this is where we measure. Another parameter like oxygen, you know that the oxygen consumption is related to the feeding. So in the morning you have a much more critical oxygen periods than in the night. So you search your system, you find what you need, and then you measure accordingly. Now, if we had the possibility to have real-time sensors all the time, this will be revealed much easier as long as they are calibrated and they're giving you the correct value, which is always a challenge, and we have to always look for that before we use the data for correlations.
Thank you. There is, of course, a comment here that is very much linked to why do we talk about automation and monitoring? Why don't we take smaller steps and help farmers to make better decisions based on good information? And what we're talking about is using monitoring as information sources to actually enable us to make better decisions, as I see it. One other comment which I think we should keep for our closing remarks is if we should have a new generation of aquaculture technologists, understanding or automation experts that are working in the interlink between biology and technology and automation. Bård, please.
I think that's a very good question. As I was pointing to it in my last comment as well, that because we need to start at the description. Description is a really good, working method. Try to describe. Forget about trying to understand something that you cannot understand until you have described it, and work with that. But there's a but here, because there are so many big investments going on land-based grow-out facilities, and you simply cannot wait for the things that are pure logic and that you're able to do already. You cannot wait. If you invest like 2 billion NOK into your land site now, you cannot wait for us to start describe and look for. You need to establish automation. You need to understand what's your margin from now on. So we should do both. And I think there's a huge part of the market that is actually has to start with a small step. And there's a new part of the market that really has to make a giant step, and we should start addressing that together, because it will take some money, but you will earn it out in the end. But it changes the way we work together, both the researcher, the supplier, and the farmer.
But this comment, I would like to get back to this about fish welfare. Do we think that automation and better monitoring systems will increase fish welfare, be it in the early stages of growing, or in the later phases, or even if we, as you said, Bård, you see the technology merging, that both the land-based and the ocean-based or the closed full grow-out systems, do we enable better fish welfare based on automation and monitoring? I put a question forward to Nikos first, and then for John to comment on.
Absolutely. My view is that if you keep the environment in optimal condition, this improves welfare a lot, reduced disease, reduced waste, and all of this have a benefit in welfare and also in performance. So the question is, where are the limits in every parameter? John said before about nephrocalcinosis. I can tell you that there are limits about Bård spoke about noise. There is what's the safe limit for ammonia in bass and bream 5-gram fish? What's the safe limit of CO2? We are farmers. We cannot keep 20 parameters in control and change one parameter and have the answer, and put this parameter in 5 different levels in order to come back with the optimum range of every parameter. So we need some help here. From my dream is to have a recirculation system inside the university and do all this stuff and give back the answers. Knowledge is power. If we know what's safe, we can replicate it. Now we're struggling between cost and benefit, and we are overloading the systems to a limit that maybe has sublethal effects sometimes.
Maybe you, John, will continue on that one.
Yeah, we were discussing this just recently in an SSPO meeting about where do we go forward with welfare monitoring, and it is looking at that more subtle effect, the fish behaviour. You know, we all know as farmers that I can go and stand and look at a tank and watch the fish behaviour and say that, well, these fish look settled and stress-free and are feeding well, and then you go and look at another tank and you see something different and you think, well, there could be something about to go wrong here. Now that's just a snapshot that I can do just at one point in time, asking any of the the guys working on the farm. But could we automate that kind of monitoring? It's been touched on before, looking at the fish behaviour in the tanks. I'm aware of one project we were involved in. It was something similar, looking at the interaction between the cleaner fish and the salmon in a pen. So feed monitoring as well, subtle changes to how the fish are feeding. Again, we know when we're grading in a system, we start getting waste coming up all the tanks, because whatever's stressing the fish in that one tank spreads to all the other tanks. So very subtle monitoring of the feed, you'll be able to pick up when the fish have started to reduce appetite. So those sort of things, when we're thinking about not just can the fish stay alive in this system, but are they happy to be here? I think that kind of technology could really drive that forward.
Yeah, I think a fish is a fish as long as it's swimming in a tank. When you take it out, it's food, and if you don't treat it properly, it will not be quality food, which is very important for us to do and see. What we're doing is actually fish farming for food and food production. When it is, there is a question here that what do you really need to monitor, and what don't you? Or what shouldn't you waste your time on monitoring? Bård, you touched upon that as a part in your introductory video, please.
I think that was a great question, a great question, because it really makes you think, and to be a bit spontaneous and just from the top of my head, I'd like to address, for instance, what my education or what my branch is doing, which is all mortality and growth as indicators of something going wrong or something being okay. Maybe that's the thing we should stop doing, because it doesn't reveal much. If it comes down to that you cannot measure everything and you need to prioritize, I would actually, just for the discussion, if no matter what, if not for something else, like to say that we know so much about the temperatures and the genetics and the feed that we pretty much detect and can predict the growth. Let's start monitoring the environment. I'm quite sure, to link that up to the latest comment as well on fish welfare. This is starting now, when we start to understand the environment, total environment, and not only the standardizing to optimize it, but maybe down the road we find what is logic, actually, that it needs to change during the value chain. The change of environment is good welfare, of course, and we're not addressing that at all.
Any other comments from the other panelists? Because that will put me on to something that was touched upon, that we should measure what is necessary and what actually creates value at a cost that enables us to do this in a proper way going forward. It was mentioned the word standardization. Is there a way of standardizing across industries or across species monitoring protocol, let me say so, that could be used? And how should we go by in creating this kind of standardized monitoring parameters that adds value to the farmer? Who wants to answer that? John, please.
I think one area that good monitoring could really help drive forward is just to really understand how the equipment is performing within the systems. If I take CO2 monitoring as an example, I've got a number of systems ourselves with different probes that we've bought over the years, and they give massively variable readings side by side. So we're resolving towards now measuring alkalinity and pH much more accurately and extrapolating the CO2 from that. And then by having that accurate measurement, we can look at how aspects of the system are performing, because you can have 10 different types of degassing, but what one is actually performing best, and it's difficult to get to that answer because everybody's system that they've spent a lot of money on is the one that they think is performing best. But if we take these readings accurately and comparably, then you can just see, because there is a fact there of what system does the job best, and that in itself will start to standardize the technology, the solutions that are given the greatest efficiency. So I think that's a key part of good monitoring to drive forward that process.
But Bård, from an industry point of view, is that a part of your competitive edge, the way that you treat and collect data, or is it something that could be a kind of competition solution to addressing a major challenge for the farmers?
A couple of years ago, 2 years ago, 3 years ago, everyone thought that the data structure and the way you set this up was the competitive advantage, but it's not. Now, most sensor system, most of the data comes, there's open APIs in all of this, so it's really, there's a lot of things that happen around that. So I really think it's not about how or the ability to put it together. We have the strength, we have the understanding, we now have open data sources. Really, it's just about doing the job. But I think John is really pointing out a very, very good example, because you're addressing the CO2, and you say in a very good way that you should know what technology provides what kind of solution or what kind of results, and think about that. There's so much knowledge on what you're actually doing, but if you see in the market on CO2 degassants, there's all kinds of different technologies still being out there, still being sold, and it makes me curious. And that's what John's saying. Why? Because it should be, we should be able to reveal through monitoring this which one is the best. They cannot all be functioning at the same level. They cannot be doing that. And we asked ourselves that question, and it's really hard to document, because there's so many subtle differences, and you need to be out there on the farms, because there is no real good setup for this. We tried. So you need to go into the farms, and they have 1 or 2 systems. They don't have them all. So who's doing this job? Maybe that we need those examples to visualize the value. And I think Nofima and the Control Aqua has answered the biological value from CO2 levels very good. And it's a few years now since we saw that linear correlation between CO2 and growth, but maybe the real biological value from that comes later in life, which is why I am very happy that we now see grow out on land, because then we will reveal this.
But Eleni, then from you as a specialist in this data treatment and automation systems, is standardization of data a key to success?
Yes. Which data and how to collect them and what standards of them are essential to get useful information from the processing. So we can't rely to not standard way of collecting this data, and also synchronized data. So there is nothing on the data, just images. If the videos are not having the standards that we should have to process and get the useful information out of it. And also how, for me, all the data need to be collected, synchronized in a standard way. And I think that researchers, since I am on the side, need to be involved on the process, at least at the beginning, before the final product, to give the inputs, both on the standardization and the synchronization and the type of data. Because then we can produce a system to have, like, for instance, fish behavior best method understanding by combining the data and the standard data and how they should be collected from different farms, different stages. But if it's finished and then it doesn't work, then I feel like it's late stage coming back to the researchers and saying, okay, the system didn't work, we collected, but then there is a big gap. So I feel here that there are billion sensors out there that we can collect, but we haven't put the standards how to collect this. And as you said, I'm from the research, so excuse me for my romantic view or like this, is that I really cannot understand why we still don't have getting all these sensors that at least are out there, even if they're not perfect, and have them installed in a case tank. And we start really using this as a case study, as Nikos said, in the lab or somewhere, to collect all this data, put what standards this data should have, so that we can get something out there that will be important. And then use this as a feedback for, yeah. So I don't know if that's helped. It's just a frustration. Why we're not there? So like Bård said on his presentation, it's just, yeah.
A challenge to that might be that each water environment and each location is different, and each species has its different parameters and its different attributes and things that needs to be monitored to enable good fish welfare and good growth and in a cost-efficient way. But I would like to take us a little bit back to Nikos and John, because in our preparation for this workshop, we were talking a little bit about showstoppers. And from in the agriculture and automation agriculture industry, there is a comment that unless automation contributes more to the biological variation than the cost of your system, you shouldn't even think of automate or to put into place new systems. So Nikos, what do you see as showstoppers?
I would say this is a difficult question because we don't know the future yet. We don't know what our suppliers will come up with new solutions and what will be the cost benefit, as you said. We are looking now in optimizing the systems and making them more efficient, better welfare, maybe less production cost in terms of reducing labor and going to precision aquaculture, but then this has to be checked versus benefit, which I don't know what will be the answer to this question. I know that the answer is related to the geographical area that you're working on. Cost-benefit analysis of technology in Norway, in Greece and in Asia is different for the same equipment because the labor cost is different. So you have to adapt to where you are and where you want to go and check the new technology under the prism of what it will give you.
That's a good comment. There is a link here to an EU project called Impact, which I would just putting up some of the parameters. And but the question popping up now is, are there any water quality parameters that are promising to be measured by sensors one day instead of spectrophotometry or titration, which is hard to incorporate into an automated system. I don't know if you would like to answer that one, Bård.
I'm not an expert on this, but there are commercial systems today gaining more and more market on that really controls the water quality in your whole system by applying small samples from each tank and bringing them to a centralized lab, and so to avoid what Nikos told us about the sensors, and you're always discussing whether it's a sensor or not. So I think those systems are quite robust and acknowledged. So I don't know much more about that, but I would like to say for Eleni, I of course I agree with what you say, but maybe also let me put in a word for not being exhausted by the data structure. For me, I think that the quality of data is we really should just start and get those data in a trusted timeline over time and regularity towards it, whether they are poor or standardized 100% or not, because I think that will in itself reveal a lot of, or get the hypothesis being more accurate in the end. So we're not even there. We don't even have those timelines. Of course, we have them in the production database, but when they're not available for us to link them with the rest of the things. And one comment on the water quality. For me, water quality should include here, when you talk about it, water speed, the hydrodynamics in the tank, especially in the large tanks. There's so much there. They live their lives in these tanks, and it's not the same to have this current or that current in that phase of your life. So we don't even measure that in a good way and get a structured data set even on that. Especially in the early phases, it could be easy to do. So yeah, I'll stop there.
Any other comments from John, Eleni? No. Then I had a yes. There is a question here. Is how often should the oxygen probes be calibrated, and how frequent should they be calibrated? Maybe that's something that the producers could provide the information on. It's beyond my scope and my knowledge. But Nikos, please.
Latest sensor technology with, I would say, cleaning every 2-3 days is fine. Optical sensors, I mean. Both in the sea and in the hatchery tanks.
That's a clear answer. And another question here is, do anyone have thoughts on improvements in water quality monitoring, both in terms of parameters and sensor performance? John?
Yeah, I was going to comment on what is already used fairly standard within the wastewater industry. Generally, they're dealing with a different range of monitoring than we are within the fish farming industry, but that technology could be quite easily adapted, and it is that taking the samples, and it doesn't need to be an online probe. They can then be processed through a system of titration or photometry. Not here in Scotland, but in England, a lot of the wastewater industry is actually charged based on what they put down the drain, and so they have automated samplers to constantly monitor that and show for certain what the parameters are. And obviously that has to be very accurate and robust because it impacts upon what they pay to discharge that waste. So that kind of technology, I think, needs to be used a lot more within the fish farming world, where we can be certain that the sensor is right and it gives real-time results that are robust and reliable.
Thank you. Then one last question to all panelists. In your view, on virtual sensors and trend into twin RAS or clone RAS? Anybody feel able to answer that? Maybe Bård, what do you think? Twin or clone when it comes to monitoring?
Oh, it's difficult. I'm an outspoken fan of digital twins, and we have just started looking into that. But no, that's as far as I go on that answer. Okay, then I said that I would come back to one question, which is also which was put forward here. That should we form a new generation of aquaculture automation experts? Should we also invest in teaching the end user, the farmers, about automation and fish farms? And from Bjarne, who was unfortunately not able to log on, his comment is that the biggest challenge to manage in the RAS is staff. Therefore, monitoring automation is needed in order to reduce manual labor. Bård, you said it's not about reducing labor. Maybe we will need technology experts to not necessarily reduce the headcount, but having more highly educated people in on the system, and to get people who are able to understand the link between biology and technology and understand the interpretation of data. Any comments to this working environment and availability of skilled labor? Nikos, please.
I will come back to my dream proposal that I said before. Where are these people going to learn? From papers only? I want a real RAS circuit in the university. When they learn, they measure the parameters, they find the limits, and they come to help us to join forces and go forward. We need to train them in real life. Of course, the professors are the tools, but without the tank and the fish that the people will learn, it will be not high value for us when they come to work.
Eleni, please.
Yes, as we discussed also a bit earlier on the preparation stage, I think educating the new generation for the new things coming, it's something if we don't address, then every automation we develop will be suboptimal because we will not have people. But Nikos, one stage is to, I agree with you, the universities to educate the new generations for the long term. But in the short term, also the industry need to increase the competence day by day of the people working in that. So I think educating the new generation is the one thing, and the second is to make sure that the competence of people working in the period, in the farms and everywhere, we adapt it with the new things we are bringing with the automation. And this is not only a role from the universities, we should be main, it should be from the research institute, but maybe also from the industry. So this was just a short comment.
Thank you, Eleni. And we are at the end of our session. I would like to thank all the participants for listening in on this. Automation is certainly an area, and monitoring is an area that will continue to impact and will continue to improve. We have touched on data quality and standardization, open APIs. We have touched upon fish welfare and also the cost of monitoring overall. Education is a key part of it, and unless we have skilled people and skilled scientists, we will not be able to move it. But there has to be a link between the science on one side and the industry and the knowledge transfer on the other side. So research is about spending money to get knowledge, and the transformation of knowledge into spending knowledge to make money is a key tool, and I hope that we will continue to enable this and be able to improve the fish welfare overall. Thank you for listening in. Thank you for your participation, and thank you to all the questions and discussions. Thank you very much, and see you at 2 o'clock. Bye.
Okay, thank you to all. So I'm going to try to wrap up these 3 sessions, which is a bit challenging. I try to keep it short. I know it's been a long day. It's been a very interesting day for me, I'm sure for all of us. So first, I need to thank everybody for their contribution, the attendance. It's been a great first RAS workshop, I believe. It's been very inspiring. A lot of topics have been covered. We had a total of up to 230, 240 participants during the day, which I think is really good. I found the discussion very interesting. And what actually strikes me the most is the lack of standardization, really, that we find overall in RAS, especially for, we've seen disinfection, for monitoring, for any kind of the sensing equipment they use, but also later on in the last session, as it was demonstrated. And this is due also to the range of systems that are used, because we always speak about RAS, but actually there's many, many different types of RAS that are being used, depending on the technology that people have been selecting or how old the systems are. And also for the species. We've been focusing a lot on salmon for obvious reasons, but obviously there are lots of species around the world that are being farmed in recirculation. So this makes things a bit tricky. That's especially true for salmon when I think about the lack of standardization, which is quite striking because there's so much more data available than any other species. But I guess that might also be part of the problem. The volume of data probably is not really what is required here. So given on the level of investment that is ongoing at the moment, I think this is clearly a top priority and a collaborative effort really is needed. And also understanding, when I come back to the session on disinfection, understanding the effect of the disinfection on the biofilters, on the microbiota, also fish, because we cannot forget about fish. And it was really nice at the end to come back to the fish. At the end of the day, it's great to have all this fantastic technology, but it is all about farming fish. So the biology really is important. So fish immunity, for example, is really also very important. And I'm sure that we can bring this topic in the next event. So in the disinfection section, there's been a lot of interesting questions and comments that came up. One of them is, should we actually disinfect regularly? Is it required when we have a system that is biosecure? I mean, that was a question that is, I think, very interesting. How do we monitor the efficiency of the disinfection? That was another one also that's important because it's traditionally done, as we've seen, through the heterotrophic counts, but obviously there's limitation to this. And how much disinfection should be done or could be done? How and importantly the fish. A little bit was said about alternatives to the usual treatments like UV, ozone, hydrogen peroxide, parasitic acids. But I think probably there's much more to be done in this topic. So there are more questions than answers, as usual, but it's mainly due to the broad range of systems also and species that we are applying RAS. Importantly, as it was mentioned during the session, and I've been taking some notes on this, RAS loop disinfection is only part of the integrated disinfection protocol. So it's quite important in the RAS. So that includes also the egg disinfection, the equipment disinfection, the disinfection throughout, biosecurity throughout. So of course, if you don't have these other elements, then probably disinfection might actually not be able to deal with the problem. The following session on data automation, acquisition, and integration was also very interesting, highlighting key questions and considerations for the future of precision farming in aquaculture. And it is clear that a lot remains to be done also. Some key thoughts that were discussed during the session include what kind of data should be collected, really, why the data should be collected, how often should be collected, and at the end of the day, to do what? Because it was really interesting to hear the comments from the panelists that I think every farm's using RAS at the moment's got lots and lots of hard disk full of data, but that's not really useful by itself. So I think it's really interesting thinking, and the most critical point, I believe. There's some source of calibration and the data integration that remain very challenging, but they are key to collect informative data. Identify also the interactions that will be promoting efficient performances. A lot of the discussion also was clearly speaking about the automation that is done mainly for tank cleaning and fish feeding, although there's still more that needs to be done for this. But what about the fish behavior and the fish welfare? There's a lot of development in open sea cages for this, but it doesn't seem to be so much yet when it comes to enclosed RAS system. And there are obviously, there's been discussion about reason why it's not so easy to monitor fish in the tanks. Overall, the lack of standardization in monitoring in the data make it very difficult to understand the multifactorial trends in a species-specific manner. This is really the big challenge here. Monitoring without safe limits or sweet spots, as we heard several times, might not be very useful. But the monitoring and the reliable data that can be used to identify the biological threshold first, then will allow to automate the system. So I think at some point it might be, my feeling is, a personal feeling is that we tend to kind of run before we can walk on some of these aspects. And it's a very, very big task to be taking on. Finally, there's a need for training. We've heard this many times during the day, training the new generation, but as John said, I think it's also the existing generation. All of us need to be trained to some extent. The technology is moving so fast that we need to keep up with all the improvement coming up. So training, it will be about bridging between academia and industry, and that's really important. And this requires, and it's been discussed several times, the availability of systems to do so. Commercial level, semi-commercial level RAS systems that can be dedicated to research and development purposes. And there's not many of them. I know there are some in Norway. I know, for example, in Scotland, we don't really have. We tend to rely on small experimental systems. I was also going to say, to me, the technology should not be at the expense also of the profitability of the sector. There's always a risk that because the technology becomes available, and I mean, there's a lot of great technology, then it would just be applied. There could be a kind of overkill. It might be more than we need, to be honest, to do the job. And then profitability is very important. It is a business, farming. And as I said, filling up hard disk with data may not be the best way forward. Making sense of the monitoring strategy and understanding the biological needs is really critical. So the last session of the day, I'm not going to say much because we spent 2.5 hours. That was really great. Well done to all the panelists. So I will just say a few words about it. And I think we all understand that the interactions in RAS are very complex, involve systems, water, feeds, chemicals, microbiota, and fish. And all of these interact between each other. So to quote John Walden from the session also, I quite like it. He said, many of us have experienced the good, the bad, but mainly the unexplained. And these unexplained are due to the complexity of these interactions, which are very difficult to simulate experimentally. So the session then focused on suspended particles, salinity, and CO2. These are among the many factors, and there's been a lot of different factors discussed. And the optimal condition for one variable will depend on the others. And I think that's what Rod said also, and it's quite very important actually to try to make sense of it. It's important for both the temporal stability of the system, but also the cutoff threshold, if you want, the sweet spot, which will be also species specific. So as it was mentioned before, the commercial-like system must be available for research, and I think that's really important. And I know that we are all convinced about this, and we need to push. Some discussion were about keeping post-smolt in seawater recirculation, and many other aspects of the RAS environment, which I'm not even going to try to wrap up. I think there was a lot and very interesting. We only said that the RAS technology is important, but so is the biology of the species that we want to farm. And I think sometimes we need to refocus a bit on, again, the biology. So overall, to finish up, a lot of questions to be answered. I think great opportunities for cross-European collaboration here between industry, academia, but also providers, and to help and support the development of farming in recirculation systems. Again, thank you to all the moderators. So Jaap, Øyvind, and Damien, you've done a great job with timekeeping and stimulating discussion. Thanks to the presenters, Chris, Bård, and Elena, who gave the latest knowledge on the topics. We also set up the scene in each session. And the panelists for the expert contribution. And I need to finish up very, very quickly. The audience also for the many question and engagement. And last but not least, the EAS staff. Don't forget Alistair and Anna in the background has been looking after us all day. And thank you very much to them. This session originally was developed with the help of Elena and Astrid Göran with me and the EAS to organize the event. So thank you very much to them. And I officially close now the event. The next RAS EAS will be in Rimini 2022. By then, we should all be able to socialize and meet face-to-face. We're all looking forward. The topics will be selected and then communicated. And to those that join the EAS event, see you tomorrow morning, start at 9 a.m. And there's also a RAS session on Wednesday morning. So thank you very much to all. It was very enjoyable.